Okay, let's talk about forests. We need wood for, well, pretty much everything. But planting a forest is a massive, long-term bet. So what if we could make that bet pay off faster? What if we could make forestry a smarter, more profitable investment? Well, let's dive in because the science behind how to do exactly that is pretty amazing.
Now, before we get into it, I want you to know this isn't just theory. Everything we're going to cover today is based on hard data from a 2020 study out of Latvia. It was published in the scientific journal Forests, so we're looking at real-world results from a real-deal experiment.
So here's the core problem, right? The world needs more timber, no question about it. But if you're a landowner, planting a forest is a huge deal. It costs a lot of money, takes a lot of time, and there's absolutely no guarantee you'll see a return anytime soon. Which leads us to the million-dollar question for anyone in the timber industry. How do we speed this up? How can we make planting a forest pay off sooner, not in 50 years, but maybe in a fraction of that time? Well, the answer, as it turns out, isn't just about planting more trees. It's about planting smarter trees. And that's where science comes in, to give forestry a major upgrade. The solution is something called tree breeding. Think about it like we do with crops. For thousands of years, we've been picking the best corn, the best wheat, to get better and better harvests. Turns out, we can do the exact same thing with trees. Select and plant the ones that are genetically wired to grow faster and stronger. This all comes down to a really important idea called heritability. It just means a parent tree's ability to pass down its good stuff, like its fast growth or its high-quality wood, to its kids. And the key finding in that Latvian study? These traits were highly heritable in silver birch trees. That means a great parent tree is very likely to produce great offspring. It makes success predictable. Okay, so that's the theory. But does it actually hold up in the real world, outside of a lab? Let's take a look at what happened when they put this to the test in a massive field trial over in Latvia. All right, here are the quick facts. The Silavava Research Institute took over 500 different families of silver birch and planted them on old farmland. Then they just let them grow. And after 14 years, it was time to see what they had. And that 14-year mark is super important. That's when you do what's called the first commercial thinning. Basically, you go in and you harvest some of the smaller trees. This does two things. It gives the best trees more room and sunlight to grow even bigger, and crucially, it's the very first time the forest owner actually gets to make some money. And this, my friends, is where it gets really interesting. After all that time, after all that growth, what did the numbers say? Did spending more on these fancy, genetically superior trees actually pay off? Now, before we get to the dollar signs, the researchers were really smart about this. They ran the numbers for two completely different scenarios. First, a low-price market like they had in 2014, and then a really strong, high-price market from 2018. This was to see if the investment held up in both good times and bad. The key number we're going to look at is the internal rate of return, or IRR. Don't let the fancy name scare you. Just think of it like the annual interest rate you'd get from a bank. It's the percentage your forest is earning for you each year. And obviously, a higher number is way better. And here you go. Look at this. In a good market, the average trees in the trial still gave a pretty solid 8.1% return. But check out the bar on the right. The top 10% of those genetically superior trees, they delivered a whopping 9.4% return. That is a huge jump in profit, all from just starting with better seeds. Now let's look at the full breakdown. Just focus on that top 10% row. Even in the bad market with low prices, they still pulled an 8.3% return. That's almost triple what the worst performing trees did. The conclusion here is crystal clear. Superior genetics win, no matter what the market is doing. So, what does that look like in actual money? Well, in that high-price market, the top performing trees brought in a net value of 1,424 euros per hectare. That's pure profit after all the harvesting costs. But honestly, this is the most important part. The study found that the net present value was positive. In plain English, that means the entire initial investment, buying the land, buying the good seedlings, planting them, it had already paid for itself, and it was already making a profit. In just 14 years, that is a total game changer for forestry. So what all this points to is a much, much more profitable future for forestry. A future that's driven by science and making smart choices right from day one. And hey, you don't have to take my word for it. The study's own conclusions says it all, loud and clear. Breeding ensures substantial income for the landowner at the age of first commercial thinning. That's not a hope or a guess, it's a proven fact. So the path forward is actually pretty simple. 1. Start with genetically superior trees. 2. Know that even if they cost a bit more upfront, it is absolutely a worthwhile investment. And 3. Profit. You can see a positive return in under 15 years, which just sets your forest up for even bigger profits down the line. So why does all this matter? Well, because when you can prove that forestry is profitable, and profitable relatively quickly, it suddenly becomes a way more attractive investment. It encourages more people to plant new, productive forests. And that's good for the economy, and it's good for the planet. And that really leaves us with a final, powerful question to chew on. We've seen the science, we've seen the financial proof, so the real question for all of us is, if we can make our forests more profitable, can we, in the end, make them more common?